So you should have your Junaluska water quality stuff open. If you don't already have this in a Google Doc, go ahead and copy and paste it. Put it in a Google Doc. So you're just gonna copy and paste this stuff, and then we're gonna go over it. Does everybody have it in a Google Doc? I don't know about you. How? Do you have it in a Google Doc?
I'm getting it in there.
Okay, so I'm gonna go over these questions with you because some people went to the creek, some did not. So it'll just be easier if I go over it with you. Did you guys get your water quality results put into it? From like when did you guys go to the creek?
We did.
Okay. Did you get your results put in, like your dissolved oxygen amounts and all that? No?
Mine was, I do remember mine.
I wrote them on the board
Mine
that day.
was 17 was a high for the temperature. I did.
Jocelyn, do you have them written down?
I have it somewhere.
I had mine on one of the sheets of paper.
I wasn't
that
there.
happened.
Okay.
It's not working.
It's not working. Well, you can just come sit down and then I'll just have to see about getting you another charger or something.
Do you want me to unplug it?
Did you find them? Okay, so what did you get for dissolved oxygen?
15.5, 13.0, 12.8, and 10.6.
Okay, so you got 15.5,
13.0,
13.0,
12.8,
12.8,
and 10.6.
and what?
10.6.
10.6. And for pH?
6, 7, 7, 6.
6, 7, 7, and 6. Okay, temperature?
17.3, 17.3.
So 2 17.3s? And that's in what?
Temperature.
What degree?
Celsius.
Celsius. Conductivity?
29.6 and 30.2.
29.6 and 30.2. Turbidity?
Nothing.
Oh yeah, we didn't get that one for here. Flow rate?
Didn't get that.
Didn't get that one. Okay, so if you didn't get those put in, then you can go ahead and put those numbers in, and you can just put it in by turbidity and flow rate. Okay, list the types of insects, animals you observed at the creek. Did anybody see anything when we were down there? Huh?
The only thing.
A beaver?
Yeah.
Did you really?
Oh wow.
When we first walked.
Oh yeah, there was.
Huh,
I
that's
didn't
cool.
see it, but he's yelled out. I saw mosquitoes.
Okay, mosquitoes. Did you see anything in the water?
Yes.
What?
Crawfish.
A crawfish. Okay. Anything else? Did anybody see any little bug things crawling on the rocks?
Oh no, I know what you're talking.
Okay, some of the other classes, and you can list these. They found stoneflies, stonefly larvae. So go ahead and list these on your number 2. Crayfish, crawdads, whatever you want to call them. We found some penny larvae. Those look like a little circle that's stuck on the bottom of a rock when you flip it over. Also found some mayfly larvae. So stonefly, mayfly, penny, larvae, crawdads. Those are some of the main things that we found. Okay, so obviously we didn't get to do Valley River because of restrictions, but just about what you know about Junaluska Creek and Valley River, which one do you think has better water quality? Junaluska Creek, okay, because the river has more houses along it, it's got more farms along it, so it's getting more pollution. So Junaluska Creek has a better water quality than Valley River. That's number 3. Okay, number 4, what did you learn about bioassessment and how is that a useful tool? So bioassessment is not something that every class got to look into, but it's where you use animals to tell if the water quality is good. We touched on it a little bit when we talked about the fish. Like there's a species of fish that we have in the streams around here that likes it cold. It likes a lot of oxygen. What is that fish?
Trout.
Trout. Okay, so you can look at the different fish that are living in the area to see if it has good water quality. You can also look at those little bugs that are in the water. So the ones that we talked about, like the stonefly, crane fly, mayfly, those things, they don't like a lot of pollution. So it's good if you have those in your water. So bioassessment is just using life. Remember, it's bio, that means life, to assess the water quality. Okay, number 5 is overall, how would you rate the water quality of Junaluska Creek? Explain your answer and use examples. So what would you say about the water quality for it? Is it good? Is it not good? Yeah, it's actually pretty good. Yeah. So Junaluska Creek actually has really good water quality. It's got a good temperature. Do you want your streams to be warmer or cooler? Cooler. The colder it is, the more dissolved oxygen it has. So if you need to think about that a certain way, think about if water's hot, it like evaporates out. Same thing's going to happen in the streams. If it's hotter, the oxygen's going to evaporate out. Okay, so that makes it have less oxygen if it's warmer. So you want cooler streams. You want high dissolved oxygen. You want a pH around what number?
pH around
What's neutral?
7.
7. Okay, remember pH scale goes from 0 to 14, 7's neutral. And Junaluska Creek has all of that. Okay, 6, what does the body shape, size of the bluegill tell you about the fish? So, let me just show you a picture of one of those.
Isn't that the body shape and size? Temperature.
So we're just looking at the anatomy of the fish. So a bluegill looks something like this, okay? So the body shape and size, is it gonna be in really fast water?
Yeah, no.
No. If it was in fast water, it would have a more streamlined body. So think about like fast cars, how they've kind of got that low to the ground shape so the air can go over them. Fish that are in fast waters have that same sort of shape to them. This has got a bigger, broader body, so it's going to be in stiller waters. That's why you find these. Where do you find these a lot?
Like,
Where out at the lake?
Toward land.
Yeah, they usually like around the docks, around the land. But they're a real big lake fish. There are in the streams some. Usually, if you find these in streams, they're going to be in a big pool, so a deeper pool. So probably down there toward that little dam area where we were, would have some of these in it. Okay, so the body shape and size is going to tell us that it lives in calmer waters. What about its mouth?
it eats, insects,
It eats open.
Yeah, see how its mouth's kind of turned upwards? So it's going to eat stuff toward the top of the water. It can eat out in front of it or at the top, but see how it's turned kind of up? That means that it kind of goes up to get its food. Okay, so the body shape and size of the bluegill tell you about the fish. So we went over all of that. The next one, if the mouth of a fish is turned up, and we already went over this, what does that tell you about the feeding methods of that fish? So if the mouth is turned up, it's going to eat stuff toward the surface of the water. So these are the ones that you catch when you're fly fishing, if you're doing the top fly. And this stuff is in the videos. Remember when that guy came here? Were you guys here that day? Yeah, when he came out there and talked, I videoed all of it, and it's all in there. But I'm just kind of going over it with you. So, all right. So we got 7. If the mouth of the fish is turned up, what does that tell you about the feeding methods of the fish? Describe how the river chub and minnow shiners are an example of commensalism. So the river chub was the one, it's a bottom feeder. Where does that mean its mouth is?
Bottom.
On the bottom. It's a bottom feeder, and it's a larger kind of fish, and it has a larger mouth. So it builds a little nest out of rocks. You may or may not have seen them in a creek. It just looks like a little.
What is the the very last word before the dash? What is that you would say?
On what number?
Commensalism.
8.
Commensalism.
Yeah. Okay.
I'm going over all this right now, so river chub takes its mouth and it makes a nest out of rocks. So it'll have a little nest made out of rocks, and that's where it lays its eggs. Minnows and shiners are smaller than a river chub, and they have a smaller mouth, so they can't make nests like that. So what they do is they go in and put their eggs in that nest. It doesn't hurt the river chub for them to do that, to reuse their nest. So it's not like one's being harmed. They just kind of use the nest. So commensalism is a type of symbiosis, and symbiosis just means that you live together. So you have parasitism, commensalism, and mutualism. Parasitism is a parasite, so one is harmed and one benefits. The parasite benefits and it harms the host. Okay. Mutualism, they both benefit, so that's like a bee and a flower. Okay, so the bee pollinates the flower, and then the bee gets the nectar, so they both benefit. Commensalism is where one benefits and the other one's not harmed, like nothing happens to it. So if a minnow or a shiner goes in and uses the river chub's nest, it doesn't make any difference to the river chub. It's not hurting it. It's already built, so that would be commensalism. So the minnows or shiners use the river chub's nest for their eggs. Hey, will you go shut that door? Okay, the next question is about a long-nosed dace. And it's in the video, and he also showed some examples of it. He did catch some of these. But the question says, what type of water does a long-nosed dace live in, and how can you tell that from their body structure? So long-nosed dace is kind of shaped like this. So this is more of the streamline shape. Okay, and it's got its mouth where?
Bottom.
On the bottom, so it feeds off of the bottom. And then it's got this kind of air-lined.
It's faster water.
So it's going to live in faster water. Okay, next question. Are rainbow trout native to North Carolina?
No.
No. Where are they native to? Does anybody remember? What continent? Asia.
Oh.
And actually, has anybody ever seen the little freshwater jellyfish
Yeah.
around here? I've only ever seen them up at Rainbow Springs. Do you guys know where that is? Okay. So the freshwater jellyfish, if you see them around here, there were some in Santila last year. I don't know if anybody's seen that video that's going around. No. They're tiny little things, but it is a little jellyfish. You can see it like moving like that in the water. They're actually a polyp that's on trout. And when it hatches out, then you'll have a little freshwater jellyfish. They're native to Asia, the freshwater jellyfish. So how we get them here is when they stock a stream with a bunch of rainbow trout. If they come from Asia, then they might have those little polyps on them. That has a little freshwater jellyfish on it, and then they'll hatch out. It's usually in the fall that it does that. But they're pretty cool to see, but I've only ever seen them once. Okay, how can you tell if a fish is stalked by looking at the fins? Do you remember what he said? Yeah, they're wore down. Why? Where's
Because
stockfish raised?
And then big concrete thing.
In them big concrete tanks. So, have you ever been like at the town pool where it's concrete and like after you get out, like your feet feel like they've kind of been rubbed raw from that concrete? Same thing happens with the trout. Their fins kind of get rubbed off in those big concrete tanks. So if you catch a trout that has those little fins that kind of look wispy, like they've been eaten off, kind of, that means that they've been raised in one of those concrete tanks. The fins will grow back, especially once they get into like a creek or a river. What's the native trout to NC?
On.
It's the brook trout. You're only gonna find those up in like faster headwaters, because the brown trout and the rainbow trout, they compete for food, so they will run the little brook trout out. That's why you only catch those up in certain areas of the creek. Okay, so the next question says, what does the mouth of a trout tell you about its feeding methods? So this would be a trout. Its mouth is straight out in front of it, a little bit turned up, so they're gonna eat stuff that's in front of it or where?
Above.
Above. Okay, 14, what are macroinvertebrates? So those are just the bugs that you look at in the water to see if it has good water quality. So that's like if you're looking for stoneflies, mayflies, crane flies. So macro means large, invertebrate means what?
No spine.
No spine, no backbone. So these are just the larger bugs that we're looking for. If it's micro invertebrates, those are going to be teeny tiny little things that you look at under a microscope. Macro are ones we can see with our own eyes. 15, what is the most important water quality test?
pH.
Nope. What would be most important to you?
Oxygen.
Oxygen. It's the most important in the water too. pH would be second because you don't want your water to be real acidic or basic. But oxygen is the most important water quality test, and that will be on your end of course test, I guarantee it. So you do need to know that one. The
Just remember
pH
fish
is
need
the
to breathe
next
too.
one. Huh?
Just remember the fish need to breathe too.
Yeah, the fish need to breathe too. Their air comes from the water. It's dissolved in it. Then their gills filter out the oxygen.
I
But
have a
they
question
basically do the
about
same
that.
thing we do.
Since like seaweed and stuff like that are the most oxygenating thing on the planet at the moment. Wouldn't that mean?
Phytoplankton.
Yeah, phytoplankton. Wouldn't that mean the ocean would have more oxygen than it would up here though?
The ocean has, it releases a lot of oxygen. It's one of the
Okay.
main releasers of oxygen.
So
That's
it's-
why it's important to keep the ocean clean, because if that phytoplankton starts to die out, then we're going to lose a lot of oxygen. It also cleanses the air because it takes in carbon dioxide. Same photosynthesis is going on in the ocean just like it is in the trees. Okay, because you've got phytoplankton, which are little tiny plants, like little algae looking things in the water. So it takes in carbon dioxide, releases oxygen. So if the phytoplankton starts to die out, then you're in trouble, because the trees can't handle it all. And they're
And we
being
also
cut down.
use the trees for more things.
Yeah. Okay, why is pH an important water quality test?
So it's not acid.
Yeah, you don't want your water to be acidic, and you also don't want it to be basic. Remember, the pH scale goes from 0 to 14. 7's neutral. Under 7's an acid. Above 7's a base. You don't want a strong acid or base. They can both harm you. Okay, explain the term eutrophication, and we've went over this before. This is just a big fancy term for too much fertilizer in the water. Okay, so this is from farms or golf courses. So fertilizer, what is its main purpose on land?
Help things grow.
Yeah, to help plants grow. Okay, so you put fertilizer on your plants and they grow. if you put fertilizer in water,
It's gonna do the same thing.
it's gonna do the same thing, but what's the plant that's gonna grow in water?
Algae.
Algae. Okay, so when you get a bunch of algae in there, from the phosphates or nitrates from the fertilizer, then the algae is going to decrease the dissolved oxygen, and it's just going to mess everything up. So the water quality starts to go down. So if you see algae in a water system, like if you see a creek that's got algae in it, its water quality is probably not that good.
Question then.
Yeah.
Like with lakes that have really big algae, does
Uh-huh.
catfish need a very big like oxygen level like catfish?
No. Catfish are like, they're bottom feeders, and they can kind of live pretty much anywhere. So they would be considered a tolerant species
Okay.
as opposed to an intolerant species.
So like catfish can pretty much live wherever they want.
Yeah, they're like a crawdad.
Oh.
Crawdads can live everywhere. And it's because they're scavengers.
Mhm.
Scavengers can kind of live wherever. When you have these real specified species like
I guess
rainbow
that-
trout or something like
That's
that, they're
pretty much true with
intolerant.
almost all scavengers though.
Scavengers will be living when everything else dies off.
Especially when it comes to humans as well.
Yeah.
They're everywhere, so. yeah.
So, catfish, crawdads, coyotes, possums are kind of a scavenger, so those kind of animals, that's why they can live anywhere and any kind of ecosystem just about, is because they're not real picky with what they eat. Now, if you had like a koala bear, which they only eat one thing that grows in one certain area, if that plant dies out, then the animal's going to die out too. But scavengers can eat anything. They'll eat live stuff, they'll eat dead stuff, they're not picky, so they can pretty much live anywhere. Okay, and then the last one is just your opinion. What was your favorite part of the activity and why?
That's funny.
So, alright, any questions about those?